Okay, in this video, I'll be going through the questions in your WA3 practice paper, set number 1. Okay, so make sure you have this correct set. Okay, so let's begin. MCQ question 1, what is the property that resists a change in motion? So this one will be mass. Okay, so it's linked to inertia. Alright, the higher the mass, the larger the inertia. Okay, Newton's first law is also known to be law of inertia. Alright. Okay, question 2. A force of 16 Newton and a force of 18 Newton act on an object at the same time. Which of following cannot be the magnitude of the resultant force acting on the object? Okay, so it cannot be 18 newtons. Okay, it cannot be 18 newtons. Okay, what is the maximum that we can have? How about we do it this way? What's the maximum force that we can have? So if I have an object and this is 60 newton and this is 80 newton, they're acting in the same direction, so a total is 150 newton. Can it be larger than that? It cannot, because they are already pushing it together in the same direction. So the maximum force that can occur from these two forces is 140 newton. Now what is the minimum? The minimum is actually if they are opposing each other, 60 newton to versus 80 newton. So the minimum is actually 20 newton. The resultant force is actually 20 newton. So it cannot be achieved. So 80 newton is not possible. How about 107 and 139? It is possible if they are at a different angle. So the two extreme cases are if they are pushing in the same direction, and the other one is when they are pushing in the opposite direction. So if you know about this, straight away you can get the answer of A. Okay, a bottle full of water has a mass of 150 grams. So mass of water plus bottle is 150 grams plus mass of bottle. Okay, when the same bottle is filled with liquid X, the mass becomes 130 grams. Given that the mass of the empty bottle is 50 grams, therefore with this I know MB, mass of bottle, is 50 grams. Mass of water is 100 grams. And mass of liquid X will be 130 minus 50 will be 80 grams. Now, what is the density of liquid X? This is quite similar to your tutorial question. By taking the density of water to be 1 gram per cm cube, that means the volume. Density equals to mass over volume. So if I want to find volume, it will be mass divided by density. Okay, mass over density. The mass is 100 grams, right? We calculated from the information given. The density is 1 gram per cm cube. So therefore, the volume will be equals to 100 cm cube. Alright. So that means the liquid X, when it's filled in a bottle, volume of X is also 100 cm cube. Right? Because the size of the bottle is fixed. So in order to find the density of X, it is mass of X over volume of X, mass over volume. So it's 80 over 100. So answer is B. Okay, so this is similar to your tutorial question. Okay, question 4. A shuttlecock is balanced at the corner of a wall. Force R is the normal reaction force of the wall on the shuttlecock. So it's acting on shuttlecock. While W is the weight of the shuttlecock, so again W is acting on the shuttlecock. You may take point P to be the pivot. Once you see the pivot, it means it's going to be a moments question. Moments question, okay? So, given that the weight of the shuttlecock is 0.5 Newton, so W is equals to 0.5 Newton. What is the reaction force R? And since this thing is balanced, where's the pivot? The pivot is at P, so this is the pivot. Okay, so how many forces are there? So first step is P is pivot. I'm revising the 6th step for solving moment question. there are two forces, W and R. How much is W? How much is R? W is 0.5 Newton. R is unknown. Okay. Now, third step, perpendicular distance. So pivot is here. Let's look carefully at this diagram. So if here is 7 cm, here is 8 cm, W perpendicular distance to the pivot is actually 8 minus 7 equals to 1 cm. So let me write my perpendicular distance for W to be over here under its weight. So for R is unknown. I don't know the size of the reaction force I'm asked to find. I'm supposed to find the perpendicular distance of R. So it is actually this distance, isn't it? Pivot is here. Pivot is this point. This is the line of action of R. So this is a perpendicular distance. So the perpendicular distance for R is 3.5 cm. Okay, so that's step 3, finding perpendicular distance of each force to the pivot. Okay, step 4 will then be calculating moment. Moment of W is equals to 0.5 times 1, so equals to 0.5 Newton cm. Moment of R is equals to R, which is unknown, multiplied by 3.5 cm, so equals to 3.5 R Newton cm. Okay, then find the assigned direction. Because R is going to be this way, pivot is here, so use the pen trick. Is going to be anti-clockwise. So this is going to be anti-clockwise. So therefore, moment of weight will then be clockwise. This is step 5. And because it's balanced, it's not moving, it's stationary, not rotating, we can apply principle of moment, which is step 6. So assigning the direction is step 5. So clockwise equals to anti-clockwise, so 0.5 is equals to 3.5 R. So R equals to 0.5 over 3.5. I got 0.143. Okay, so the best answer for this MCQ will be B. Okay, so the answer is B. Now, question 5, which of the following diagram shows a ball in stable equilibrium? Stable equilibrium means that if I move it, it will come back to its original position. So answer will be A. So B is actually unstable. Okay, because once I apply a force, it will never come back to its original. It will just roll down. C as well, it will be unstable. And D is neutral. Okay, no matter how you roll it around, it will still be at the same position. But A, if I move it higher, the CG rises. Remember, we talked about this in class. And then it will fall. But for here, the CG falls. For B, it will continue to fall. Okay. For D, it doesn't matter. The CG is still at the same position. Okay, question 6 is a simple mercury barometer. So, if there is no mention of it, we can take it that it's ideal. That means over here is vacuum. So, there's no pressure inside. So, remember the two steps is, the first step is draw arrows. Draw arrows when surface has pressure. Okay, so that's actually PATM here. And because over here is vacuum, we don't need to draw the downward arrow. And in this case, we don't need to find same liquid, same level, same pressure. Okay, they are asking, does not cause the height of the mercury column to vary. If there's changes in atmospheric pressure, it will vary. Okay, if there's a change in your value of gravitational field strength, so what is gravitational field strength? It is G, right? So pressure equals to rho GH. Okay, so if the G changes, right, the H will also change. Okay, so for if there are gravitational field strength, then based on this formula, the height will change. Okay, but evaporation of mercury from the barometer reservoir, so as I get lesser and lesser mercury, but because it is PATM that is pressing down on the mercury and pushing it up, so I don't care how much mercury I have left there. Of course, if we are left with one drop, then yeah, it's the most extreme case. But actually, if the mercury were to disappear lower and lower, the height of this mercury column will correspond to the amount of PATM. And as long as my PATM don't change, my evaporation of mercury will not affect. So answer is C. But what happens if the temperature of the mercury actually changes? As you know, mercury will expand or contract based on changes in temperature. So this will actually cause the height of the mercury column to vary. Okay, so of course, we keep in mind that the temperature remains constant, then we can do an accurate comparison of the changes in your atmospheric pressure. Okay, question 7, the pressure produced by a cubic block is P. What's the pressure of the length, breadth, and height? So all three dimensions are doubled. So we actually did this in our notes. You can refer to it, but the answer is C. Okay, because the weight is multiplied by 8 times, and the area is actually 4 times. Okay, now we go to section B. It shows a uniform box. Stationary along a slope is stationary. Draw and label all the forces acting on the slope. By right, this thing should slide down, but it doesn't because of friction. So there's normal force, and in this way, there's also friction. Okay, so friction must be drawn along the two surfaces. Okay, and because by right this thing's supposed to slide down but it didn't, it's because friction is propping it up, pushing it up. Okay, so question 2, it shows all the forces acting on a toy helicopter at a moment in time. The mass is 1.5 kg. This mass is not force, okay, it's not weight. So the weight is actually 15 Newton, right? How do I get weight? W equals to mg, so equals to 1.5 multiplied by 10, which is gravitational field strength, so I have 15 Newton. It is rising upwards at a constant acceleration of 2.0 meter per second square. So if you think that if there is acceleration, there's going to be F net. Okay, and this acceleration is upwards, therefore F net is upwards. So I will indicate my F net here. Okay, in fact, I can actually calculate the value of F net. F net equals to ma. I have the mass of 1.5. The acceleration is actually 2, so F net is actually 3 Newton. Calculate the upward force generated by the propeller. So is the upward force 3 Newton? No, that is actually the F net. So if I were to draw a free body diagram, I will have 15 Newton acting downwards because of the weight. Recall, free body diagram actually shows all the forces acting on the body. So there must be a upward force. Maybe I call it lift or the upward force, right? And there is also a resultant force of 3 Newton. How do I get 3 Newton? Because I am given acceleration, I have mass, I can get my F net. And F net is calculated to be 3 Newton upwards. Therefore, lift force must be 18 Newtons. Okay, if not, I'm not able to get 3 Newton with the weight of 15 Newton acting downwards. When a toy helicopter reaches a height of 10 meters, it hovers at this elevation. That means it's stationary over there, not moving up or down. Explain in terms of forces why the toy helicopter was able to hover in mid-air. In terms of forces, that means the lift force is equal and opposite to weight, right? Since it is equal and opposite, I can adjust the lift force by adjusting the speed of rotation of the rotor, right? So it is equal and opposite to weight. That means it is going to be 15 Newton upwards. Okay, so my weight is 15 Newton downwards. Since there is no F net, okay, F net equals to 0, it will be stationary at that location. Okay. Now state the action paired to the weight of the toy helicopter. So this helicopter has weight due to attraction of Earth, right? So action reaction pair, this is actually Newton's third law. Newton's third law, so it must be equal and opposite forces. They must act on opposite body. act on opposite body. So the weight is actually acted on the helicopter by the earth. That means the helicopter must be pulling the earth up. That is the action-reaction pair. Okay. Then question 3, it shows a plasticine bob held in place by two strings X and Y. Plasticine has a weight of 4 Newton. So I indicate 4 Newton here. By using a scale vector diagram, you cannot use sine rule, cosine rule to calculate. By using a vector diagram, determine the magnitude of the tension within string Y. Okay, so this is actually 40 degrees. This is actually 60 degrees. Okay. So the length of the string doesn't tell me the size of the force. Okay, so if you draw out your ceiling, it is very wrong. You should instead draw 4 Newton, okay, according to a scale. Then you are given the direction of force at X. You are also given direction of force Y. Okay, so force X and Y and 4 Newton together, there is no F net because it is in equilibrium. Okay, so this is a question of no F net, right? That means resultant force of Fx and Fy is equal and opposite to 4 Newton. Okay, the resultant force of Fx and Fy. Okay, so please don't be confused when I say there's no F net in the whole system. When I say there's no F net, it means Fx versus 4 Newton and Fy, their resultant is 0. Okay, but now if I focus on Fx and Fy, the resultant force of Fx and Fy is equal and opposite to 4 Newton, so that they can counteract each other, and therefore there will be no F net in the system. So for this, I really need you to try drawing. Okay. Okay, then question 4, basketball is released from the top of a very tall building. It falls vertically downwards and undergoes decreasing acceleration. What does decreasing acceleration means? That means acceleration is decreasing. Okay, I know I'm just rephrasing, but what's acceleration? Velocity is increasing. Okay, this is what we mean by when there's acceleration. But how do we add in the decreasing? So I will add in that velocity is increasing at a decreasing rate. Okay, so this is your kinematics you need to know. Now, forces acting on this basketball is air resistance and weight. Okay, the weight is constant, but air resistance increases as speed increases, right? So explain in terms of the forces acting on a basketball why it experiences decreasing acceleration. So the first part is when I first drop it. Okay, first drop, first part. Okay, speed is low, therefore air resistance is low. So if I were to put it in a vector diagram, this is my weight. Remember, my weight is more or less constant, so my air resistance is very low, AR. Okay, so is there a F net? Yes, there's F net downwards because I use W minus AR. Yeah. So there's F net. So if there's F net, there's going to be acceleration. All right. Then, since it accelerates, right? The speed increases. So if the speed increases, air resistance increases. So I draw a free body diagram again. The W is more or less constant, but this time because the speed increases, my air resistance is going to increase. Okay, and you can see from my diagram, my free body diagram, the air resistance is still not equal to W, right? The W is still larger, so my F net is slightly smaller in value, so F net is actually still W minus air resistance. Okay, so there's still acceleration, but the acceleration compared to, so I call this A1 and A2, A2 will be less than A1, right? Because of the air resistance increasing. Why did the air resistance increase? Because as it fell, initially, there is acceleration, the speed increases. So that increases your air resistance. Students tend to miss out this part. The air resistance increases as speed increases. Okay, it's very crucial part to add in so that you can put it into a free body diagram and draw the same diagram as mine. So you can actually visualize how the Fnet looks like. So do you agree that my acceleration for part 2 is less than part 1? Right? So therefore, it will experience decreasing acceleration. Eventually, at this point, there's still acceleration. Although A2 is very much smaller than A1, you can't deny that there is no increase in speed. So the speed still increases. If the speed still increases, then your air resistance will eventually increases until it is equal to weight. Therefore, no Fnet. No Fnet means no more acceleration. So what will happen to this basketball? Will it stop in mid-air? No, because it was already moving, right? You'll move now with constant velocity. Okay, because there's no more acceleration, right? So you need to be able to write these few points. Okay. Okay, then question 5, you look at this, it's definitely a moment question. State the principle of moment. So sum of clockwise and clockwise moment about pivot is equal to sum of anti-clockwise moment when a body is in equilibrium. Okay. Now state the position A, B, or C in which the 200 Newton force exerts the largest moment. So in order to have largest moment, now moment equals to force times perpendicular distance, and since every part of the force is 200 Newton, so what matters is the perpendicular distance. If my perpendicular distance is the largest, then you will exert the largest moment. So pivot is here, my 200 Newton, remember to draw a line of action of the force, and this is my perpendicular distance. So I do this again, so this is my perpendicular distance, I do this, you notice that the 200 Newton actually passes through the pivot. So for A, the perpendicular distance is 0. Okay, so A will actually have no moment. Okay, you always need to use perpendicular distance for your explanation. So largest moment will be C. Explain your answer. It has the largest perpendicular distance of the line of action of 200 Newton to pivot. Alright, since moment equals to force times perpendicular distance, and force is the same, always 200, right, for the 3 cases. So it has the largest perpendicular distance, it will have the largest moment. Okay. Okay, then question 6 is a mercury barometer placed next to a meter rule. Take G to be 10 Newton per kg. So this is our G. So determine the atmospheric pressure. So again, if they never say anything, we can take it that this is vacuum and ideal barometer. So there's no pressure. So first step, draw the arrow to indicate on the liquid level that there is pressure acting on it. So this is my PATM. So this PATM will actually push the mercury level up to a certain level, okay, based on the difference in pressure. So determine atmospheric pressure indicated by the mercury barometer in cmHg. So I will need this height, okay, I will need this height, and here is ending at 90 cm, here is about 14 cm. So the difference in height, it is actually 76 cm. So they want us to leave it in cmHg, so it will be 76 cmHg. Where does the G of 10 Newton per kg go in? It's not here. It's not in here, right? Because this G is the same throughout. So if I know that this place has a higher pressure, it will be greater than 76 cmHg. If I go to a place, example, of lower pressure, then it will be something like 40 cmHg. So very quickly, I just compare this value of the height. I will know whether the place is higher pressure or lower pressure. Okay, given that density of mercury is 13600 kg per meter cube, determine the atmospheric pressure indicated by the mercury barometer in its SI unit. Therefore, it must be in Pascal, right? So using the liquid pressure formula, pressure equals to rho GH. The density is 13600. I don't need to do any calculation, conversion, because it's already in SI unit. The G is 10. I also don't need to do any conversion, but 76 cm is not SI unit, so I need to divide by 100. Okay, so with this, I should get a value of, I'll get a value of 103360 on my calculator. So to leave it in 3SF will be 103 kilopascal or 103000 Pascal. Okay, so as long as I leave it in Pascal, I'm okay. Okay, so question 7, it shows a hydraulic press. The hydraulic press works on the same pressure is transmitted throughout the liquid. Okay, we have two different surface area. So please think of the area. If it's given in meter square, you are quite safe. If it's given in as a diameter, pi r square, you need to be careful. Okay, please refer to my notes. So determine the minimum force needed to lift a 1500 Newton. Okay, so the way to solving this kind of physics question is identify what is common among the two cases. Okay, so the pressure is constant. Okay, the pressure is the same, transmitted equally, so the pressure at P is equals to pressure at Q. But what does the pressure formula looks like? It's actually force P over area P equals to force Q over area Q. So we look at this, we have area P. Okay, we don't know what is force P, unknown. We have area Q. The load is 1500 and this is equal to my FQ. So I substitute everything in. FP over 0.5 equals to FQ over 2. Okay, so I will get FP to be equal 375 Newton. Okay, so we do see that a smaller force is actually able to lift up a larger load. Describe how your answer in A will be different in air bubbles or trap. This is inside your tutorial answer. Alright, so I think this is the end of this paper.